Okay, so here's our position function. You can plug in like a t equals 3. You can find where your position is 3 seconds after dropping it. We've talked about that, but we want velocity. So here's for part A. We saw that v sub A was the limit as h goes to 0 of s of a plus h minus s of a all over h. We're going to have to work this limit out. And let's see what we've got. So plugging in a plus h everywhere, you'd get negative 16. And here's a plus h squared plus 512. And then we could say minus, well, if I'm just plugging in an a, that's way simpler, isn't it? You're just going to get this. And then we're going to go ahead and try to work this out and simplify it. So let's see what happens as we do that. First off, I just want to quickly point out to you, to save a little bit of space, that a plus h squared would be a squared plus 2ah plus h squared. So that's really what negative 16 would get distributed to. So let's see if we could work that out. As you're cleaning this up, you'd say negative 16, you get negative 16 a squared minus 32ah minus 16 h squared. You've got your plus 512, but now I'm going to distribute this negative to both of these, and you can think, well, wow, what's going to happen here when we do that? Sorry, having a little trouble here with the pen. That would be a plus 16a squared minus 512. Right now, this looks really, really, really messy, but there's some great news. Certain things are going to cancel out. Hope you can see a lot canceling out, really. The negative 16a squared and the plus 16a squared are going to go away. The 512 and this minus 512 are going to go away. And then you can more or less see if I plug in a 0 for h, the top and the bottom will both be 0, won't they? So factor out an h. Let's do that. And then hopefully you'll be able to very quickly see what's happening. Remember, we are doing this in the most general way right now. You could say here's a negative 32. Oh, pardon me, we're factoring out an h. I factored out an a there. So that's negative 32a minus 16h. And then down below here, we've got our h. So our h's are going to cancel out. And when I plug in h equals 0, what are we going to be left with? Negative 32a. Guys, here's what we're really talking about for part A. We're saying, hey, you want to find the instantaneous velocity? It's negative 32a. It's negative 32a, where a was the number of seconds that we are working with. So for part B, they're going to say, well, that's all well and good if you have a formula, but I want to plug in t equals 2. That is, you're really saying, let's let a equal 2. That's literally what you're saying. So if you do that, you're going to say v of 2 would be negative 32 times 2, and that would be negative 64. Let's talk about units. What's our distance unit? It's feet, right? It was 512 feet. What's our time unit? It's in seconds. So we'd be at negative 64 feet per second. So that's not an average velocity. That's at that particular instant. That sandbag would have been having a velocity of, because it's negative, that indicates it's dropping down. So it's losing 64 feet per second. Okay, we doing okay? Well, the big question is, how fast, or what is the velocity the instant it hits the ground. Wow. So, yeah, we're going to, when it hits the ground, let me bring this over here for part C. When it hits the ground, what is happening? Well, will the velocity be zero? Think about it. Imagine like a big sandbag or a football or whatever is dropping down. When it hits the ground, would the velocity be zero? No, the velocity being zero means it's not moving, right? It's going to be moving quite fast, won't it? What's going to be zero, though? Your position. Look at this. Here's where you're starting. You got 512 feet. S is your distance from the ground. You can see that right here. When it hits the ground, how many feet is it away from the ground? 0. So you could say when S is equal to 0. So we're going to set 0 equal over here, and we'd have negative 16t squared plus 512. Wrote that backwards. But let's go ahead and see if we can solve for the time when that's going to happen. Of course, right now you might want to divide by 16. Just isolating our t here. So we'll go 512 divide by 16, and that's going to be 32. So you got to take the square root, only take the positive, and you could say, wow, there's the square root of 32 seconds. Now, could we, of course, simplify that? Yeah, you could, but look, V of A is equal to negative 32A. You'd say, hey, at this moment, at radical 32, let's see what our velocity really would be. And let's get a decimal here. Since we'd probably be using a calculator, we might as well just get this rounded off at the very end. Negative 32 times radical 32. Hey, that's negative 181. By the way, AP rounding on the College Board's test, they want you to go to 3 decimals. So we'll have 0.019. And that would be feet per second. Hey, that's going almost triple the speed that we originally had, right? Just previously at t equals 2. If you think of it that way, right? So wow, as we'd expect, as it has more time to fall, it's going to increase in its overall speed. Ignoring the negative, it's going way faster, isn't it? Another way to put it, look at the floor here. 1 square is a square foot. So in 1 second, it's going to cover 181 of those floor tiles. So that's pretty fast, right? All right. So that's what we have, just for that example. Let's very quickly just continue on here. The average rate of change was the secant line slope that we have here. Instantaneous rate of change has this limit. So let's see if we can punch this out right here. It says, find the average rate of change of y with respect to x on this given interval. And you look at example 2 right here, you think, man, this just looks strange. I think a lot of kids don't like this alternate form as much. And undoubtedly, a lot of you probably look at this and think, oh man, if only we could use the other form that we had. And that's great too, don't get me wrong, but we can't have escapism and just forget about this form. The College Board holds us accountable to it. And maybe the first thing that we've got to make sense of is, okay, so what do you think A is in this problem? What's A? It's 4, right? What's A plus H? 5. It's your start and your end. In other words, H itself would be a 1, wouldn't it? You're saying start at 4, move 1 step to the right, but your A plus H, your ending is 5. Guys, if you look at it that way, then it's not so bad. And then you'd say, well, if that were the case, then H, of course, would have to equal just a 1, wouldn't it? Right? So, you can hopefully see that. If you start at 4, you're ending right here. So, what are we talking about right now? This right here becomes f of 5 minus f of 4. And if h was equal to 1, then we're just going to put that over 1. Wow. Another way to put it, sometimes kids will say, oh, Mr. Dobner, wasn't this really just y2 minus y1 all over x2 minus x1? Yeah. This would be like your f of 5 minus your f of 4. And then you'd say, well, here's your 5 minus 4. And what is 5 minus 4 down below? There's your 1. You see that? Wow. So what is f of 5? Well, we're going to come right up in here. So f of 5 is, and by the way, you could get some help with the calculator if you'd like. You could say here's 3, and here's a 5, and we're going to square it. And we'd say minus 5 times 5. Of course, we can get that help. And you can say that's 50. So there's your 50. Minus, well, what's f of 4? Well, my goodness, what's kind of cool? We could just come back here and say, you know what? We wanted to change that 5 to a 4, didn't we? And when we do that, we're just going to get 28. 50 minus 28. What's 50 minus 28, guys? 22. There we go. 22 skidoo. By the way, that was Mr. Clifford with the funny skidoo line there. All right, so that's your average rate of change. Sometimes kids will say, hey, that's feet per second or whatever. Guys, we don't know units. We don't know units, and we can't really create the units. Who knows? Maybe this is an econ problem. Who knows? Maybe this is the change in money over change of units produced. Regardless, that's what we have. But then we're going to move to B, and for B it says find the instantaneous rate of change with respect to x at the left end point. So what they're saying is find y of 4, or find your y of a where a is equal to 4. So let's go ahead and write that out here. The y of a, by definition, is going to be the limit as h goes to 0 of f of a plus h minus f of a all over an h. But we want y of 4. We're trying to find the instantaneous rate of change just there. So that's f of 4 plus h minus f of 4 all over h. So now we're not working in general just with an a, but hey, get a load of this. This could get to be a little bit ugly. We can work this out though. You could say f of 4 plus h. Well, here's the idea. Wherever there is an x, look, I just want to say this much. F of x is equal to 3x squared minus 5x. It's kind of like f of a blank equals 3 blank squared minus 5 blank. So if I'm saying f of 4 plus h, I've got to put in that 4 plus h wherever there's a blank. Hopefully you can see what we're talking about here, right? So that's your f of 4 plus h. By the way, you could have put a triangle in here, and then you put a triangle there. Put a smiley in, you put smileys in. Could put your own name in there if you want to, right? Whatever you put in the space, you put all around. So this is 4 plus h squared minus 5 times 4 plus h. But here's kind of a cool little addendum. Do we know what f of 4 is? We just did that, didn't we? That's 28. All right. So finishing this thing up, we just have to expand. This is 16 plus 8h plus h squared. So 3 times 16, you get 48. Here's 24h plus 3h squared. minus, this is 28, no, just a